Hi, I'm Yusuf. In this video, we will talk about floor and wall with IPW. As you can understand from its name, it can see the blank, it can see the IPW in process workpiece. Let's see how it works. Our blank is above the Z0 of the part. I define the floor and can see that X extends the cut area until the blank. I choose zigzag and define the Z passes, and it creates 3 passes because it's 3 millimeter longer than the parts. Okay. Now it's time for the blow face, blow floor. It see the walls. I define a depth for cuts and choose follow periphery. And click generate. It can see the blank, it can see the cut parts of the blank and create the toolpaths according to this information. We can change whether inward or outward and click generate. Okay, you can see a different behavior here. You can think that there is an uncut area, but it isn't uncut actually. You can see this moves and it isn't. There is no uncut area. But if you don't want this move, you can choose add finish passes and have a profile move on walls like this. It will extend the time, but it will have a safer toolpaths. Okay, let's look at other parts. The most 3-axis parts are like these parts. They generally don't have too much formed areas. They are prismatic parts generally. And the toolpaths is created using curves or phases. They generally cam guys don't generally use blank information. If we want to use floor and wall, for example, let's choose here. Okay, zigzag. If I choose part outline, it will cut these areas, so I can't use it. I can use minimum box. Okay, 10 millimeter and 1 millimeter Z pass and click generate. It didn't see the blank, it didn't use the blank information, and we can cut it. But let's look at the toolpaths. Freezing. Okay. If you look at toolpaths, this blank is a cylinder, but toolpaths has corners. So there is too much air cuts. If you the part number is, for example, 10, it won't be a problem. But if you cut thousands or hundreds of these parts, this is a problem. So you shouldn't do any air cuts. For that, you must use floor and wall with IPW. Okay. Zigzag depth per cut 1 and click generate. Look, the operation solved where to cut. I didn't change any blank outline or part outline or minimum box. It can understand where to cut. And the best is it didn't make any air move. It just cut the blank. Okay. I copy and paste and choose other floors. I should wait some because it calculates the IPW. It sees the IPW, it calculates it and creates the toolpaths according to this IPV. It doesn't make any air move. It doesn't cut any air move. Okay. Okay, in the last floor, the two sides are cut. Let's look what kind of IPV it will create. Okay, and it can see these sides and creates toolpath according to that, and you can see the other floor. Let's choose this floor and see what happens. It can cut these two walls, but I think it can cut some of them. Let's look. Oh no, it cuts. Okay. There isn't a problem. Okay. Let's try to cut other areas. I choose a smaller tool. Specify cut area floor and choose this floor. Walls. Follow periphery. 1 millimeter depth per cut and click generate. Let's look how it cuts. It didn't cut this part. We will extend the tool paths. Containment tool overhang. We will write it 100 and generate. It will extend the tool paths. Okay. Until now, all floors has a wall geometry, has a neighbor wall geometry. Okay. But in this area, this floor geometry doesn't have all neighbor walls. What will we do now? We choose the floor and let's see what it do. It cuts the cutting area according to this wall geometry, but it will not solve our problem. It must extend until this cylinder. Okay, we deactivate the automatic walls, specify floor geometry, and choose these walls. Okay, I can see the cutting area. I choose that wall too. Okay, and see the cutting area. Click generate. Okay, we choose something wrong. Okay, and we click generate. It cuts the area, but there is an uncut uncut part left. I choose the cut area and choose that floor again and click generate. Let's see how it cuts. Okay. As you can see, floor and wall is very useful for these prismatic parts. 3 axis or 4 axis or 5 axis. If you watched carefully, I didn't define any axis because the tool axis is normal to first face. When I use a rotary table, it doesn't see, you can't see it in this window, but the rotary table changes its axis. But I didn't change any, I didn't tell it, for example, change from 0 to 9 degree. I didn't tell them. The post changed them. Let's see how it do it. Post process. Okay, you must prepare the template first, of course. Look, I write A and it is A minus 9. Okay, and A0. Why it is minus 9? Because it is 9, 0 and it's minus 9. As you can see, you don't have to define the rotary tables angles. The post automatically finds it, and you can use the full roll with IPW for prismatic parts. Thank you for watching. If you have questions, please ask me on comments, and I will try to write the link of these parts on under my video.